Hello and welcome to this video on hydrate formulas. So in order to talk about hydrates, we need to know a couple of things with terminology. So a hydrate means water. Something has water. An an means without, and hydrous, so without water. And so an anhydrous is just an ionic compound that does not have water, while a hydrate is going to be an ionic compound with some specific number of water molecules that's bound to it. And so in order to determine our hydrate names and formulas, what we want to know is that we're going to write the ionic formula with a dot followed by the number of water molecules. And so we're going to use Greek prefixes to signify the number of water molecules. And so our example that we're going to spend some time with today is going to be copper 2 sulfate pentahydrate. And so copper 2 sulfate is the ionic compound, and then pentahydrate, 5 water molecules are going to be bound to that. And so we have CuSO4 for copper sulfate, and then we use this dot between them, kind of like a time symbol dot, with 5 H2Os to represent that 5 penta, or that pentahydrate, or 5 hydrates. Okay, 5 water molecules. And so we have some problem solving steps that we want to utilize. We may need to do some additional calculations in order to get the mass of the compound and the water, so the anhydrous and water. And so once we know those, we can calculate the number of moles of the anhydrous, which is the ionic compound, using its molar mass. We can do the same thing for water using the molar mass of water, which is 18 grams per moles. And then finally we're going to divide each one of those, for 1 and 2, by the smallest number of moles, just like we do in empirical formulas. Now, the smallest number of moles is going to be the anhydrous. Okay, so there's going to be some, at least one, if not more than one, water molecules. And then we're going to write that formula. So let's take a look at an example of this and actually do a calculation. And we're going to use copper 2 sulfate pentahydrate still as our example, but we're going to now analyze that data. And so the first thing that we need to do is go ahead and take a look at the anhydrous, which is the copper sulfate. Okay, so we have this formula for copper sulfate hydrate that had 2.5 grams, and then we heat it up. And when we heat it up, we evaporate off the water molecules that are bound to it, and we end up with the anhydrous of 1.59 grams. So if we are looking at that step number 1 that we had from before, so step number 1 in our problem solving, we're going to start with that 1.59 grams of our CuSO4, and we're going to change that to moles. So for every 1 mole, there's 160 grams. And I get a really small number, so 0.0099375. So 99375. Okay, that's moles. And then we're going to do the same thing for water, but the problem is we don't have the mass of water directly. So if we find the difference between the hydrate and the anhydrous, we will get water. And so for step 2, we actually have to find water first. So 2, we need to know the mass of water, mass of H2O. And so we're going to take 2.5 minus 1.59, so 2.50 grams minus the 1.59 grams, and that gives us 0.91 grams of water. Okay. Once we have that, now we're just going to go ahead and convert that into moles, and so I'm just going to go ahead and do that directly here. Okay. And so we know that we have 18 grams for every 1 mole of water, and that gives us 0.05055. Okay. Now, those are our 2 moles. We're going to divide by the smallest number, which is obviously going to be the top one. Okay. So if I divide this by itself, 0.0099375, I get 1. Okay, and that's 1 of the copper sulfate, so we're only going to have 1 of the ionic compound. Now let's go ahead, I'm going to move this number down, so we have our 0.05055 moles of water. Okay, and I'm going to go ahead and divide that, so divided by the 0.0099375. I usually just keep a lot of these numbers since they're really small and big numbers, or a lot of value trailing place values, I just keep that in my calculator. And so when I do that, I get a number that is going to be 5. And so that's going to be 5 of the waters. Okay. And so when I write this out for my formula, I'm going to have our CuSO4 dash 5 H2O. And that's how we use data. We will do some experimenting in class oftentimes in order to determine this as well. And so sometimes that looks a little bit different even with our actual lab data. I hope that was helpful for you.